Hello, and welcome to day 12 of learning ML from chatgpt. Let's get started. So yesterday we learned about convolutional neural networks for image classification using, we learned about, the filters and the kernels, like 303 kernel, then we had 32 filters, then went on to 64 filters, and then we flattened it, then we had some dense layers, 64 neurons, then 10 neurons, when we used the first 3 layers had rel activation, and the last layer had soft max activation. So now we're on day 12, which advanced convolutional neural network techniques. So fine-tuning, transfer learning, data augmentation. Okay, using a pre-trained model, ResNet for image classification. Okay, so we'll be able to learn about that. So please give me day 12's lesson. Okay. So there will just be a bit of an addition to yesterday's. Oops, I'll go to okay. Concepts 1. Transfer learning. Definition. Transfer learning involves using a pre-trained model which has already been trained on a large dataset and adapting it to a new smaller dataset. The idea is that the pre-trained model has already learned useful features like edges and textures that can be applied to similar tasks. Why it's useful? It allows us to leverage the power of large models without needing large datasets or immense computational power to train from scratch. It's especially effective when the new task is similar to the original task the model was trained on. Okay, so that's pretty simple, transfer learning. Then data augmentation. Definition. Data augmentation involves applying random transitions like rotations, flips, scaling, etc. to training data, artificially increase the size of the dataset and improve model generalization. Okay. Why it's useful? It helps prevent overfitting by introducing variations in the dataset, ensuring that the model doesn't become too dependent on specific patterns in the training data. 3. Fine-tuning. Definition. Fine-tuning is a process where we start with a pre-trained model and tune the model by training on our new dataset. This usually involves unfreezing some of the top layers of the pre-trained model and updating the weights for those layers while keeping the base layers frozen. Why it's useful? Fine-tuning allows for more precise adjustments of the model on the new dataset, especially if the target dataset differs slightly from the original one. Okay, so now to the code example. So in this example, we'll demonstrate how to use a ResNet 50, which is a pre-trained model on the ImageNet, and to fine-tune it for a new data set. So step 1 is to import libraries. So we first import TensorFlow, then the Keras, just lots of Keras things. Step 2, load pre-trained ResNet model. We'll use ResNet 50 as a base model. The include top equals false argument means we're removing the fully connected layers at the top and just using the convolutional base. Okay, so we just because it's basically what we did yesterday. We didn't have dense layers, like fully connected layers at the start. We just had them at the end. So base model equals ResNet 50, weight equals ImageNet, and include top equals false. That because we just said we remove that. Then input shape. So 224 by 224 is the size of the images. I assume an ImageNet dataset, and then we have 3 is the RGB channels. Base model trainable equals false. Freeze the base model layers so that they do not update during training. The top and just everything's fully at the top. Okay, so we're just using the pre-trained bit. I assume that means. Okay, so then data augmentation for training. Okay, so we're having training data generator equals image data generator. We're rescaling it to just I think it's like we have 255 as the pixel. We're putting it into a range of 0 to 1, I think. Rotation range 40. So this is the data augmentation. width shift change, height shift change, shear range, zoom range, horizontal flip. Yeah, this is for data augmentation. So train data equals train data generator dot flow from directory, path to train data. Okay, so val data gen image generator rescale 255 validation data. Val equals data gen flow from directory, path to validation data, target size 244, because that's the input, like image input, batch size 32, class mode categorical, builder model. I just assume like we use very similar ones on every for every image generator. Well, and we just have to change some things depending on like what the data is and the size. We had a few custom layers on top of the frozen base model, including global average pooling layer, followed by a dense layer for classification. Okay, X equals base model output. So add new layers on top of the base model. Okay. Average pooling is 2D. We're adding a dense layer, so a fully connected layer. We're having the activation function as relu. Predictions. This we're using softmax here because remember softmax it gives probabilities for every different. With 10 neurons, it has a probability for neuron 0 and neuron 9, and every probability adds up to 1. So model equals model inputs, base model input, outputs equals predictions. Okay, so this is a bit different to what we've seen before because we pre-trained. Like it's got to be generic, the pre-trained model, kind of in order to be reused on other data. Model.compile optimizer, this is what we used yesterday. Fine-tune the model. After training for a few epochs, you can unfreeze some of the top layers of the base model to allow fine-tuning. Fine-tune at 140. Optimizer equals optimizer is Adam 1e minus 5 lower learning rate. Okay. Model.fit epochs. So where do we actually use this? Fine tune at. I can't see where we're actually. Is it a variable that we've declared? I think it is. I don't know. Fine tune at. I don't know for that one. But then we're fitting the model with training data, then 10 epochs, and validation data. Evaluate the model, just do model.evaluate like we've seen before. Okay. Task is pre-trained on a custom data set. Okay, so please provide the full code. Just easier than copy pasting it. So I'm assuming we're going to need to have our own image data set, but I reckon we can still use this one we used yesterday. Can't remember what the exact name was it. Now please add let me see. Saphir, was it? Data set, sorry? No, not here. CFAR. 510 data set for the pre-trained model to use. Okay, let's see. So we're importing the C510 dataset. So yesterday we used C510 dataset. It's got like a frog, automobile, a plane, boat, and like several other. It's got 10 different image types, and they're already pre-labeled. Okay, so assume we're having, we're gonna have to change. Oh, the pre-trained was not. Let's see, where are we? Base model. Oh yeah, okay. Now let's put this into the Google Colab and run this. Might take a while again. Okay, we're connected to the Google Cloud Engine rather. Still importing TensorFlow, so oh, okay. We're just loading the C510 dataset. But I'm hoping it won't take long as it's a pre-trained. Yesterday it took like 40 minutes, but as it's pre-trained, it should be able to do it relatively quickly. But there's like 60,000 images, so as you can see where the green sort of arrow is here, even resizing it takes a good chunk of time. Okay. Let's see. String resized. What? Just been cancelled. Don't know why. Hopefully it's been cached or something, otherwise... Nope, it has not. Okay. That's the one downside to machine learning. It takes a long time to train these models. Especially if you're doing this on a laptop like I am. There's like OBS, it's taking up with compute power. But actually, no, it's on Google, it's running on Google servers, so it doesn't have much to do with it, my laptop. It may be faster if I run it on PyCharm, but I tried, I think, importing the libraries, but my PyCharm's also, oh yeah, it keeps crashing for some reason. I do not know why this is though. I'll try it one last time. If it doesn't, I'll just have to move on. Keeps crashing after the 40-second mark. So it's loading data. Oh yeah. Okay. So what I said before, where it's like 1 divided by 55. Oh no, that bit's gone now. So yeah, this is converting. Yeah, 0 and 1. So ResNet's pre-trainer 224 by 224. It looks like. So yeah, it keeps bugging out at 41. So I'll just see. Okay. So yeah, thanks for watching, and I'll see you in the next video. Goodbye.